Our next speaker will be Laurie Abadie, who will be discussing the Human Research Program. I guess Eric Hoagland will be presenting to Laurie.
And hey, Sam, this is actually Eric Hoagland. Laurie did have to check out. Can you hear me all right?
Yep, we sure can.
All right, very good. So I'll go ahead and get started and give the HRP status for this workshop today. So you please go to the next slide. So the Human Research Program is looking to build on the existing research that we're currently doing on the Earth and in ISS and apply it to what we plan to do on Artemis in the lunar orbit or lunar vicinity in order to answer those questions that the Office of Chief Health and Medical Officer has posed as risks for human spaceflight in order to enable our Mars missions. So again, we're building on the base that we have here on Earth with some of our analogs, adding to what we're doing in ISS that provides us that ability to evaluate microgravity as well as some of the special environmental hazards that are associated with low Earth orbit. And then we're adding to that with what we'll be able to investigate in the lunar vicinity in order to answer some of those questions. If you go to the next slide, please. Specifically on Artemis, what we are looking for in terms of the impacts to the 5 hazards that have been identified for human research are the ability that the Artemis missions will give us to evaluate that deep space radiation that we can't get in the low Earth orbit, as well as the impact of altered gravity, or those G transitions that we currently don't get when we do a lot of our ISS research. We're hoping to take some of these answers and be able to answer those questions associated with things like what are the impacts for the long duration missions as they go to Mars for the 6 to 8 to 12-month duration to get there? What will the crew members be able to do? What are the additional impacts to their system that would impact their ability to perform activities? And then what, if any, benefit or detriment do those G transitions elicit that would impact some of the countermeasures or operational controls that we're looking to develop in order to enable the crew to come back safe and happy? We go to the next slide, please. So again, what is our mission philosophy for Artemis specifically? We're looking to be as unobtrusive and non-invasive as possible. We understand that there are limitations of the resources associated with Artemis for not just operations, for not just utilization, but all operational impacts. It will be very important for us to be able to minimize what we are trying to do in terms of resource use and crew time impacts. So we're trying to do this as unobtrusively and non-invasively as possible. We're also looking to do kind of an in-depth characterization of the individual. So we're taking the data that we're collecting from the crew, we're adding to it as much metadata that we can collect from the vehicle or from the other programs as they collect data and add it to our research, as well as evaluating the training and the in-mission resources that are required to do these operations, since this Artemis mission analog will be a very good look at what it will take in order for us to be successful in a much more Earth-independent mission like we'll have in the Mars mission. And again, looking to apply that research approach as a continuum across all of the programs and missions to enable this move to Mars. So we're looking to start with Artemis 2, and I'll talk about that here in a second, build and add to our capabilities, add to our operations, and make it so that by the end of, or by we get through the later Artemis missions, we can use that as more of a model for an analog for a true Mars mission to evaluate and do a shakedown of what we are planning to do or what we're recommending in terms of countermeasures and controls. Next slide, please. So what this slide is trying to show is kind of our understanding of the limitations of what we can do as we move across that crew autonomy spectrum that you see on the arrow on the right, on the top there. So as you can see on the Earth side, we have our analogs, where since we control the majority of that environment, we have many research opportunities. So we're focusing the majority of the research that we can do on the ground on our ground analogs. As we go to Leo and then Artemis and then to Mars, there's an understanding that those research opportunities decrease as the mission constraints increase. Again, the point of these missions is to bring the crew back safe and healthy. So understanding that the capabilities that we'll have as the crew autonomy increases, decrease the amount of the type of research that we're used to doing on the ground in Leo. So we're using that to define our philosophy in terms of designing the experiments and designing the research that we'll be doing to enable these Mars missions. If you go to the next slide, this arrow chart kind of shows that plan as we have our early payloads identified here on the bottom. As the Artemis mission durations increase, we kind of are operating under some of the similar assumptions to the capabilities and technology that we have here on Earth and in ISS. As we move forward in Artemis, we're going to work on becoming more Earth, or maintaining that Earth reliance, but moving towards Earth independence. Eventually developing these hybrid Earth-reliant, Earth-independent activities, as it especially pertains to crew autonomy, being able to perform medical activities without as much interaction with the ground, and trying to move towards that fully Earth-independent crew health and performance system, and then perform a shakedown, and hopefully in the later Artemis missions, as we are proposing to perform a number of extended Artemis in order to be more analogous to what a Mars mission would be in terms of duration and exposure to microgravity, and then gravity afterwards. If you go to the next slide, please. I'm not going to go through everything on here, but this is just a very quick snapshot of our current plans for the first few Artemis missions. You'll notice we don't have the Artemis tail numbers on there for this official discussion, but as you can imagine, you can probably identify which one of these missions we're talking about here. For our first Orion-only mission, we are planning a very small set of in-flight payloads. We do plan to do a number of pre- and post-flight collections to augment this data set, but we do have 3 approved for the first Orion-only mission. As we go to the first surface mission, we're looking to expand our capabilities and evaluate what we can perform or what data we can collect once we get that first return to the moon, as you can see on that lunar surface list. With Gateway, we're actually incorporating a number of international partner studies as well as HRP. So we are part of what's called the Gateway Tiger Team for the Human Health and Discipline Working Group. And through that group, we've identified a number of not just NASA, but international partner payloads that we're looking to perform on Gateway. So we're helping to manage that list. And then as we go to the standard Artemis, or what we could call sustaining, where we'll have the full architecture in place, we look to expand our capabilities and expand the number of studies and payloads that we're looking to operate across the Artemis platform. So from Orion all the way to Gateway, HLS, and onto the surface. And again, as the surface capabilities increase and we have new activity or new capabilities to take advantage of, such as the potential for cold stowage, starting with that first sustained.
Don't leave on. You leave on Facebook.
So is that a question or an open mic?
Looks like we have a hot mic from somewhere.
So we are looking to build on everything that we've started with Artemis 2 and increase the capabilities as we go.
I'm sorry, we're getting some crosstalk here.
Yeah.
Okay, thanks. Go ahead, Eric. You're a little bit over time, so
finishing up here. Yeah, so next slide. I'm not going to go through anything here. This just shows some of the examples that we submitted for our Artemis 3 payloads. And finally, the challenges. This is something HRP has had to work through as we perform our research. We are following the humans, so we'll be interfacing across the entire architecture, not just one platform or the other. We're looking at that time course adaptation, so that's why we need these longer duration missions in order to understand how things change. There's a lot of unknowns once you get past 6 months to a year, so we're looking to evaluate that. Everything is crew consent based, so again, we'll have to ensure that we are doing this ethically moving forward. So that's another piece we'll have to look at. And then international partners, we'll be collaborating with them on Gateway, and if they ended up on the rest of the Artemis mission, we'll work that as well. And of course, time to collect and crunch the data. As we get these answers from the Artemis missions, how that impacts the Mars architecture is something we'll have to work with those programs to make sure we have the time to give them the answers they need. And that's all I had. There's a number of backup slides, but I'll be hanging out for any questions after this section. Thank you.
All right, thanks, Eric. That was a great update.